Now, whenever you make any material for any mechanical applications, it can be a single metal or it can be a composite. You need to do some fracture studies. Now, suppose there is a crack that has been generated in the material, and now due to application of stress, this crack may grow. This crack might not be initially visible to us. The size of the crack usually is, if small, and on application of this stress, this crack may grow. Now we will now concentrate on the factors at the crack tip which actually leads to this growth of this crack. Or what is the amount of stress that the material may withstand before the crack can grow? Now, according to Griffith, he actually laid a criterion. It's called Griffith's cracking criterion. In which it is said that if the amount of stress exceeds a certain quantity, for example, if that is written as Gc is equal to pi sigma square A by epsilon, where sigma is the amount of stress that is applied. Now, if this quantity exceeds Gc, then crack growth will take place, and A is the crack length. Now we will take an example to better understand this. Suppose there is a glass plate which is subjected to stress of about 69 GPa. Okay. Oh, sorry. This is supposed to be the elastic modulus, not the and the stress applied is 40 MPa. And the strain energy or the in the glass or specific energy is sigma s, and gamma s is 0.3 joules per meter square. Now what we need to find out is the maximum length the surface of the flaw is possible before the fracture takes place. So what we will do, we will have to find out the quantity A. Now A is equal to 2E sigma s by pi sigma square. Earlier we had written Gc is equal to pi sigma square A by E. So we can see that Gc is basically equal to 2 gamma s, twice of the specific energy is actually the Gc. So coming back to the previous problem, if you write again the equation, A is equal to 2E gamma S by pi sigma square. If I put the values, the value of A comes out to be about 8.2 maximum. This is the maximum length of the crack length possible before it starts to fracture, because if this is the crack, it will start to fracture from here, this amount of length. Now whenever we are applying a stress in an already present crack, there are basically two modes of crack growth. One is called the opening mode, mode 1, where stress is applied in this direction and the crack starts to open up. This is mode 1. Another mode 2 or mode 3, I should call it, they are grouped into one, are the modes where sliding and tearing takes place. For example, this is the crack. In mode 2, sliding will take place, which will cause the crack to grow, whereas in mode 3, tearing will take place, which will also cause the crack to grow. So basically, for calculations, we take this mode 1. So the amount of stress required to open a crack is given as sigma x is equal to K, which is the stress intensity factor, divided by 2 pi r. This is done in planar coordinates, where we have an r theta. This is the coordinate, and we have a function fx theta here. So this is for the x-axis. Similarly, there will be y-axis. The only thing that will change here is, instead of fx theta, it will be fy theta. And lastly, we have a shear stress tau xy, which will again be the same thing, only thing that it will depend upon fxy theta. Now this fx, fy and fxy are basically functions. Fx theta is equal to cos theta by 2, 1 minus sine theta by 2 into sine 3 theta by 2. Fy theta is cos theta by 2, 1 plus the same thing that we have here, and fxy theta is sine theta by 2 cos theta by 2 into cos 3 theta by 2. Now if the plate is actually according to the dimension of the crack, then we can say that sigma z is equal to 0.